Hey, Algebra 2, want to take you through the quick quiz 2 real quick. I'm going to leave the answers up here and just talk my way through them. What we did is we took a look for our domain. Again, we go small x to big X. Well, there's no small x there's no stopping to the small x, right? Our smallest x is going to be negative infinity. Our biggest is going to be 9 because I actually have a dot. I have a stop there. So our biggest is 9. So what I say is x is less than or equal to 9 because that includes 9 and everything less, everything going left. That's for my domain. I need to write that 3 different ways. I've got inequality, my set, and then for the interval notation, since I set it equals 9 because it's got that solid dot, I put a bracket with that one. I put a bracket saying that it could equal 9, but we don't know the number. We don't know an exact value for negative infinity, so we're always going to put that parenthesis. For the range, I do have a low value of negative infinity down here as well because I have an arrow pointing down. If I have an arrow that has a little bit pointing down, my range, my low value is negative infinity. I don't have an arrow pointing up, and I don't have any values up in here, but I do have a biggest value right here of 5. And in my opinion, I thought it touched 5. If you don't, that's fine too, as long as all your notations match. So what I said was y is less than or equal to 5. In other words, you've got 5 is the biggest, and then it goes down from there. So y is less than or equal to 5. Set notation, the set of all numbers in y such that, again, that's that vertical bar, y is less than or equal to 5. Interval notation, however, negative infinity to 5. I put that nice bracket on 5 because I said it touched up here. Up here. As for end behavior, I look on the right hand side as x goes to positive infinity. My y values, well, it doesn't have an arrow. If it doesn't have an arrow, it doesn't have end behavior. It doesn't go to positive infinity. X doesn't go to. So that does not exist. That's where DNE comes in. And I look on the left-hand side, I look on the left because that says X goes to negative infinity. My arrow is pointing down. My Y values are going to go to negative infinity. So that's where that end behavior comes from. Increasing again, we talk about X intervals. It's increasing until right here. So from negative infinity to negative 5. And then it increases again from here until here, which is 2 to 7. For decreasing, it starts decreasing here and stops here. So from negative 5 to 2. And then also from 7 to 9. Now, one of the questions I had was, do I actually absolutely have to have the parenthesis or can I have the bracket this time? I would accept either one because we didn't have a real big conversation about that when you have an endpoint. I would accept either one of those as long as you're justifying that. Where are we at? Relative maximums. We've got two. We've got one peak here and one peak here. That is the y value is 5 at x equals negative 5, and one is 4 at x equals 7. Again, the top two, the intervals, these are x intervals. Don't forget that, okay? Those are x intervals. Down here, these are coordinate points. These are coordinate points, negative 5, 5, 7, 4. And for the minimum, 2, negative 6. Zeros of the function where it crosses, we've got negative 7, negative 2, and 5. Okay, got those guys in there. On which is it, where is it positive? So in other words, where is it above the y-axis? Anything up here. So that would be from here until here, because these values are above. So from negative 7 to negative 2, they're positive. And from 5 until 9. And again, this is one of those things where I was okay with having the parenthesis or the bracket there for this one. Where are they negative? Well, they're negative from negative infinity until, and then they stop being negative right there. So from negative infinity to negative 7. Then also from here until here, my function values are below the x-axis. So from negative 2 to 5. Down below, you've got different rates of change. Again, these are intervals. These are intervals, so I'm looking between two x values. I said between negative 7 and negative 5. If I draw the points between there, that's a positive slope or positive rate of change. There are an infinite number in here. Negative 2 to 0 for a negative, I said from here to here. That's a negative rate of change. I like that. Then for a 0 rate of change, I went from negative 7 to negative 2. One of the most common ways to do the 0 rate of change is pick two consecutive y-intercepts. That's kind of what I did. I'm sorry, two consecutive x-intercepts. That's what I did. Yeah, we don't have more than two y-intercepts here. On the second page, here's what I did. That was supposed to be x is greater than or equal to 3. And so in here, what I did is I said my domain values, the smallest domain that I have is -3, and it could go on, my x values could go on to positive infinity. So I just looked to see, what is the value at x equals -3? Well, it happens to be 1. I plug that in. The value of the function when x is -3, -3, which is +3. It's a weird way to say it. 3 minus 2 is 1. So I plot that point, and that is a solid point. That's a filled in solid point at -3, 1. And then I look to see, well, these are linear functions like we've been doing for a while now, right? My slope here is -1. I'm just going to pick another point. I go down 1, right 1, down 1, right 1, because it's a negative slope. And it's just going to keep going. It's going to keep going because there's no stopping x from going to positive infinity. But what happens when my x values go to positive infinity, my y values go to negative infinity. My lowest y value is negative infinity. My biggest y value is 1. So I also have to take, and again, this was writing the range in the same notation as the domain. This was inequality notation. So I end up with my range, the biggest value is 1. It's got to go all the way down, or y is less than or equal to 1. For more explanation, go ahead, check out the other videos and the quick quizzes and stuff like that. Hope you guys are doing well. Take care. We'll talk to you soon.